Welcome to Learning Hub X Maths. Imagine you have 24 apples and 36 oranges. You want to pack them into identical boxes. Each box must contain the same number of apples and the same number of oranges. And very importantly, no fruit can be left over. So here's the big question. What is the greatest number of identical boxes you can make? This is exactly the kind of problem that the highest common factor, or HCF, solves. To solve this, we need to find the number that divides both 24 and 36 exactly, and not just any number. The largest one. That number is called the highest common factor, or HCF. Step 1. List the factors of 24. We find numbers that multiply to give 24. The factor pairs are 1 times 24, 2 times 12, 3 times 8, 4 times 6. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Step 2. List the factors of 36. We find numbers that multiply to give 36. The factor pairs are 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Now step 3, find the common factors. Common factors are 1, 2, 3, 4, 6, 12. Step 4, choose the largest one, the highest common factor. HCF is 12. That means we can make 12 identical boxes. Now, the key question, how many apples go into each box? How many oranges go into each box? If we have 24 apples and we are making 12 boxes, we divide 24 divided by 12 equals 2. So each box has 2 apples. Now for oranges, 36 oranges, 12 boxes. 36 divided by 12 equals 3. So each box has 3 oranges. So each box contains 2 apples, 3 oranges, no leftovers. HCF tells us how many equal groups can we make. Division tells us what goes into each group. Here is a school party problem. A school bought 24 sandwiches, 36 juice boxes, 60 cupcakes. They want to pack them into identical party bags. Each bag must contain the same number of sandwiches, the same number of juice boxes, the same number of cupcakes. And very importantly, no food can be left over. What is the greatest number of identical party bags they can make? When students see a word problem, they often panic. But word problems are not difficult. They are just maths questions written in English. Our job is to translate English into maths language. Let's look at the question together. What is the greatest number of identical party bags they can make? Instead of looking at the numbers first, look at the words. What are the important words here? Greatest number, identical, party bags. Now let's translate them one by one. Greatest number means the largest possible number. Identical means equal groups. Party bags means groups. So the question is really asking, what is the largest number of equal groups we can form without any leftovers? And that is exactly the definition of highest common factor. So mathematically, we write HCF 24, 36, 60. Once we have translated the word problem into maths language, the solving part becomes easy. This time, we will use the ladder method. First, write the numbers side by side like this. We look for a number that divides all 3 numbers. Can 2 divide all of them? Yes. Now, can 2 divide all 3? No, because 9 is not divisible by 2. So we try 3. Now, can 2 divide all 3? Yes. Now, there is no number greater than 1 that divides all 3. So we stop. Multiply the common divisors, which is all the numbers on the left. 2 times 3 equals 12. So the HCF is 12. In the ladder method, we divide by numbers that divide all values at the same time. Then we multiply those common divisors. But wait, what goes inside each bag? Are we done just because we found 12? No. Now we interpret the answer. We have 24 sandwiches and 12 bags. So what do? We divide. 24 divided by 12 equals 2. So each bag gets 2 sandwiches. Now for the juice boxes. We have 36 juice boxes and 12 bags. Divide. 36 divided by 12 equals 3. So each bag gets 3 juice boxes. Now the cupcakes. We have 60 cupcakes and 12 bags. Divide. 60 divided by 12 equals 5. So each bag gets 5 cupcakes. Now we are truly done. Each party bag contains 2 sandwiches, 3 juice boxes, 5 cupcakes, and there are no leftovers. HCF gave us the number of bags. Division told us what goes inside each bag. That is how maths connects to real life. We just solved this using the ladder method, and we found the HCF is 12. But here's something important. Suppose the numbers were bigger. Would the ladder method always be the easiest? Not necessarily. So the question is there another way to find the HCF? Yes. Instead of dividing all numbers together, we can break each number into its prime factors first. This method is called Prime Factorization, and it helps us see the structure of the numbers more clearly. Ladder method divides together. Prime Factorization breaks apart. Let's try it. Step 1, prime factorize. 24 equals 2 times 12 equals 2 times 2 times 6 equals 2 times 2 times 2 times 3. So 24 is equal to 2 to the power of 3 times 3. 36 equals 2 times 18 equals 2 times 2 times 9 equals 2 times 2 times 3 times 3. So 36 is equal to 2 to the power of 2 times 3 to the power of 2. 60 equals 2 times, 30 equals 2 times 15 equals 2 times 3 times 5. So 60 is equal to 2 to the power of 2 times 3 times 5. Now we look for prime numbers that appear in all 3 numbers. The common primes number in all 3 numbers are 2 and 3. Now take the smallest power of each common prime. For 2, the smallest power is 2 to the power of 2. For 3, the smallest power is 3. So HCF equals 2 to the power of 2 times 3, which is 12. Same answer as ladder method. In prime factorization, we take the common prime factors with the smallest powers. We are building a number that fits inside all 3 numbers. So we can only use what every number has in common. We take the smallest power because that is the most each number can share. Today we learned what the highest common factor is. We learned how to translate a word problem into math language. We learned how to use factor pairs to find the HCF. We also learned how to use the ladder method and the prime factorization method to work out the HCF. Most importantly, we learned that HCF helps us find the greatest number of equal groups with no leftovers. That is how maths connects to real life. If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and turn on the notification bell so you don't miss future videos. I'll see you in the next lesson.